Today I thought I would talk about the most basic thing in orbital mechanics. Orbits. What are orbits? Why do they happen? What is gravity? I will also be answering the most important question ever asked in physics. Does the moon fall? But first, what is an orbit? To answer this question, let's start throwing some stuff. One major issue that high school students face is that they learn all their physics on a flat earth. For example, a question would be asked to a high school student. A ball moving at a velocity of 12 meters per second at an angle of 45 degrees and with the gravity's downward acceleration being 10 meters per second squared, calculate how far the ball will travel. Now you could use math and physics to figure out the ball travels 14.4 meters. But let's put that picture aside for 1 minute and look at a different picture. This one. This is Earth. Now, let's do some math. To be more specific, let's use Pythagoras' theorem. We all know a squared plus b squared is equal to c squared. Now at this point, you're probably asking, why are we doing this? And the reason we're doing this is so we can calculate the curvature of the Earth per kilometer. So let's do that. Step 1. Draw a line from the center of the Earth to the surface. Next, we draw a line signifying 1 kilometer. Then, connect all the dots to get a right angle triangle. Using this side as a, the radius of the Earth, which is 6,371 kilometers, we can solve for c, which becomes 6,371.000078 kilometers. This shows for every kilometer you walk in a straight line, you actually move 0.000078 kilometers down, or 7.8 centimeters down. Now, let's apply that to the previous question of throwing the ball. So, accounting from the curvature of the Earth, we actually gained 0.11232 centimeters by curving away from the Earth. This is the principle of how orbits work. They occur when something is thrown so fast, they fall towards the Earth and gain the same amount of distance they've fallen. That answers the most important question ever asked in physics. Does the moon also fall? And the answer to that is yes. Yes, it does. And that's what keeps it in orbit, along with its velocity. But how do we know what that velocity is? Well, let's turn to a third picture right now. I'm going to ask why the ball falls. The reason is gravity. You see, gravity is a very special thing of this universe as it pulls things down. The formula for gravitational force is given as this, where capital G is Newton's gravitational constant, or 6.67 times 10 to the minus 11. Lowercase m is the mass of the small object, uppercase m is equal to the mass of the big object, usually Earth, Sun, Moon, and r is equal to the distance between each object. For an object in flight in a circular path, there is a force called centripetal force, given by the formula mv squared over r is equal to force, where v is the velocity. The most important thing to note is the formula is centripetal means center seeking. Or if I was to draw it in a diagram, I draw it like this. This means if I was to write negative mv squared over r, the force I would be pointing the other way, or a force that wants to leave the ground. This means that the net force for an object being thrown is greater than 0, because if we write this down mathematically, gravitational force minus centripetal force is greater than 0. This is because the gravitational force is greater than the centripetal force. For an object to be in orbit, the net force on the object has to be equal to 0, or gravitational force minus centripetal force is equal to 0. Solving for v, we find the velocity required to orbit a body. Now we can do some magical algebra to show that v orbit is equal to the square root of capital G times capital M divided by r, where m is the mass of the body you are orbiting and r is the distance away from the body you are orbiting. That's for a circular orbit. There are different types of orbits, but that's enough for today. Please comment, tell me how I can improve, and please, I'll see you next time.